Hello, in this section we will explain three DLL duplex protocols. Previously, we have explained simplex protocols, but we said the simplex protocol is not good in performance. So how to improve the efficiency? The solution is try to achieve full duplex communication. So the first question we want to ask is how to achieve full duplex data transmission. It's easy to do that. Two separate simplex data channels can be one full duplex data transmission channel. And that is a circle for data in both directions. And also we can try something more to try to improve the performance. The thing we can use is called piggybacking. It is about to temporarily delay outgoing acknowledgements so that they can get a free rider on the next outgoing data frame. Because now the data communication, the data transmission is bidirectional. So the question is, how long should the receiver wait for the piggybacking? An ad hoc scheme is to wait a fixed number of milliseconds. So this involves a timer, we call it egg timer. It's a timer for acknowledgement. So we are going to try to explain the sliding window protocols. A sequence number is associated with each transmitted frame. The sequence number range from 0 up to some maximum 1, 2 powers n minus 1. That will be recursively repeated. A window is a list of sequence number. The sender remains ascending window with the sequence number corresponding to frames that has been sent out but not been acknowledged yet. Or those frames can be resent in the future. Whenever a new packet arrives from the network layer, it is given with the next highest sequence number, and then the up edge is advanced by 1. When an acknowledgement comes in, the lower edge is advanced by 1. The receiver maintains a receiving window with the sequence numbers corresponding to frames it is permitted to accept it. When a frame whose sequence number is equal to the lower edge of the window is received, it is passed to the network layer, and acknowledgement is generated, and the window is rotated by 1. So we try to explain Protocol 4, the principle of Protocol 4. It is 1-bit sliding window protocol, which means the window size is 1. The sliding window maximum is the maximum sequence number, and which is 1 in Protocol 4. So the window size is 1. The initial value is sequence number equals to 0, and acknowledgement is 1, because now it is expecting to receive sequence number 1 from the sender. The window sliding scheme works like that. A sends a frame first with the sequence number 0, acknowledgement number 1. That is frame A0. When B receives A0, B sends back piggybacking acknowledgement. So that's frame B0 with sequence number 0 and acknowledgement number 0. Because B wants to acknowledge A, A0 has been successfully received. When A receives acknowledgement to A0, it slides the window. It slides the sending window, sends the next frame with the sequence number 1, acknowledgement number 0. That is frame A1. So now we have an example of the communication in Protocol 4. It starts with A, try to send a frame to B, and then B will send back frame. So if we check the diagram, we will find out each frame gets 3 components: the sequence number, acknowledgement number, and the data. A sends A0 first with the sequence number 0. That acknowledgement number is 1. It is invalid. It just tries to say this is the initial of the communication. When B receives A0, B will send back B0, and it carries the acknowledgement for A0. So it happens like that, and this is a normal case of the communication in protocol 4. We then will try to say protocol 5. It is called go back N protocol. For the receiver, it just needs to discard wrong frame and all the letter frames. So for the receiver, the receiving window is 1. For the sender, it just needs to resend the wrong frame and all the letter frames. The basic idea of protocol 5 is like that. The receiver's window size is 1, as we explained. That is to say, the receiver only accepts frames in order. The receiver discards all frames following an arrow and sending no acknowledgement. So eventually, the sender will get timeout. After the timeout, the sender retransmits all the unacknowledged frames in order, starting from the damaged or lost one. So in the diagram, we explained when we get an arrow for frame 2, then all the frames after frame 2 will be retransmitted. So that is protocol 5. Now we try to say protocol 6, the last protocol of the 6 elementary protocols in DLL. It is called selective repeat protocol. So things get different with protocol 5. For the receiver, it only discards wrong frame, but store all the letter correct frames. For the sender, it just needs to resend the wrong frame. The working principle of protocol 6 is like that. Protocol 6 accepts frames out of the order, but pass packet to its network layer in the order, which means the receiver needs to buffer all the frames out of order but correct. When the receiver receives all the frames whose sequence number fall within the receiving window, the receiver does not pass this frame to the network layer until all the lower numbered frame has already been delivered to the network layer in the correct order. So again, we get an example to explain how protocol 6 works. In this example, again, we get error for frame 2. And when frame 2 gets error, but all the other letter frames, they will be successfully received and buffered. When frame 2 gets retransmitted and successfully received by the receiver, then all the buffered frames will be delivered to its network layer in the right order. So it's the end of this section, and we have one question for you to think about. For protocol 5 and protocol 6, the window size is very important. Can the window size be very large, or it is limited by something? So try to think about what is the limitation of the maximum window size in protocol 5 and 6. Does window size have any relationship between the maximum sequence number or other issues? That's it of this section. Thank you.